Okay, welcome back to Terence Payne Engineering, okay, and Electrical Studies. What I want to do is look at finding the resistivity of cable, okay, and to find the resistivity of cable we have to use the formula R equals rho L over A, okay, rho, RHO, right, let me just put that there, let me give that as a text there, okay, I'll put that in as a text, okay, let me just move that down a bit. Let me move it down a little bit, okay. R H O rho, okay, and that's, let me just see if I can get this a little bit smaller so it doesn't take up too much space. Okay, and that is just get my diagrams in. That is rho, okay. And that is rho L over A. Okay. Now let us look at a particular. Let us look at that should be T there, okay. Should be T there, okay. At a particular problem. Example 1, okay. Find the resistance of the field coil of a motor where the conductor cross-sectional area, CSA, is 2 millimeters square. The length of wire is 4,000 meters and the material resistivity is 18 microohms per millimeter. So let me read that to you again. Example 1. Find the resistance of the field coil of a motor where the conductor cross-sectional area is 2 millimeters square. The length of wire is 4,000 meters and the material resistivity is 18 microohms per millimeter. Okay. Now using R equals rho L, R equals rho L over A, we need to find bear with me for a moment, just make sure I get this the right way around, okay? R equals rho L over A. Rho is given in millimeters. In rho is given in millionth of an ohm, okay, per millimeter. Okay, now that's my interpretation. Now you may well interpret it in your own manner, informing your own style of learning, and that is important that you do. But this is how I'm looking at it from my perspective. You will need to look at it from your own perspective, and hopefully we arrive at the same conclusion. So here, what all I'm doing now here is R equals 18 over 1 million times 4,000 times 1,000 over 2. Now, why over 2? We multiply the 4,000 by 1,000 to bring it to millimeters. Because it told us something up here about the cross-sectional area here is 2 millimeters square. Okay. And the length here is 4,000, okay, meters. Okay. Now here now, what I've now done, because I've brought that to a given value, make sure, yes, okay. Now, what I do, I tend to rewrite out the question. So here all I've simply done is rewrite this out, okay, for myself. And it's just the way I work, okay. So we then have here 18 over 1 millionth times 4 millionth over 2. Now, I may be looking at this quite a long-winded way, which I agree with you in, but in order to try to illustrate this in a manner where most people can comprehend it, I'm hoping that this works for most people. It may not do, but again, it's just my way of working. You will have to find your own way of working, okay? Now, here you'll notice that I've taken my time I've written this out here, and I've written it out here again, okay? And that is for my own edification. And you can see that when you do that, that is the answer you're going to come up with, 36 ohms. Okay. Now make sure you arrive at that for yourself. Okay. A simple way, all I would do is simply R equals rho L over A, and that would be 10 to the minus 6 times 4,000 times 10 to the 3 over 2, and that will give me 36 ohms. Okay. That's the simple, easy way. That's the way I would normally do it. Okay. But in order to try to illustrate the process as to how we arrive at that decision and solution, I thought that I would follow and show you the process that we go through. Okay. Now I know some of you are quite bright, so I could be wasting my time, but remember those people who may not be as bright as yourselves, we have to take them into consideration. Okay. Okay, and there we are. Okay, and here we have, okay, now again, example 2, a copper conductor has a resistivity of 17.8 microohms per millimeter and a cross-sectional area of 2.5 millimeters square. What will be the resistance of a 30-meter length of this conductor? Okay, so let's extract our information. Okay, and here we have our data again, and we extract the information to show that we know what we're looking for and can find. Okay, there we are. Okay, again, R equals rho L over A. Okay, and again, this is my long-winded way of doing it for you, and I hope that it works for you. Okay, if it doesn't, then adapt it and make it your own. And I've said here we are in millimeters already. Okay. Okay. So all I've done here now is bring that down, follow that calculation process stage by stage. For that length of cable, we've got 0.2136. And that is your answer. Okay. Now what have I missed out here? Tell me. What have I missed out here? The units. I've missed out the units. Okay. So again, I've been working with myself. I'm doing this my own handiwork. I missed out the units. Okay. So you can see for that for that 30-meter length of conductor, it will have a resistance of 0.2136 ohms. Okay. Okay. Let me just see if I need to move this. Example 3. Okay. A copper conductor has a resistivity of 17.8 microohms per millimeter and is 1.785 millimeters in diameter. What will be the resistance of a 75 meter length of this conductor? What will be the resistance of a 75 meter length of this conductor? Hang on, why have I repeated this twice? Yes, I repeated this twice. So what will be the resistance of a 75 millimeter length of this conductor? Okay, whichever wrote this some time ago. So we can ignore that part. We can ignore that part. So the question is simply, what will be the resistance of a 75 meter length of this conductor? Why I wrote it twice, I have no idea. Okay. To answer this question, you need the cross-sectional area, CSA. Okay. First, to do that, we need to look at the diameter and apply a formula to find the cross-sectional area. Therefore, to find the cross-sectional area, CSA equals pi d squared over 4 equals 3.142 times 1.785 times 1.785. Now that's just the way I do it. You could just put it in 1.785 squared if you wish. But I wanted to show the process as to how we bring our diameter square and multiply it out into its relevant parts. Okay. Now that gives us this. Okay. Make sure you can arrive at this for yourself. Again, put pen to paper, and we have here our 2.5 millimeters. Okay. So we know the cross-sectional area is 2.5 millimeters square. Okay. We then need to find the resistivity R equals rho L over A, and that gives us 0.534 ohms for that length of conductor and that relevant appropriate. Okay. Okay, I hope you found this useful. Okay. And let me just take it from the top, make sure that we can follow. I have everything on screen. Okay. We'll go back a little bit. Okay. Okay, thank you. I hope you found this useful. Bye-bye.